So I was saying that the motivation for this particular MBI project comes from a Portuguese project where we have been working on. It's called AIM Health. In fact, we projected an AI secure and trusty application for alerting its users for possible COVID symptoms, even when they are asymptomatic. And this led the way for the presentation I'm going to make next. And especially because of the special paradigm we're using here, which is from one end treating personal and sensitive health data, and the questions of security and trustworthiness, and of course our paradigm is based on a federated machine learning implementation on edge computing architecture based on microservices. So the project I'm on MPI AI that I'm presenting today, it's the generalization of this approach for a more normalized and standardized approach to be included into MPI efforts. So we pretend to support the collection, the processing, and access to health-related related data based on secure federated learning and distribution of updated AI models. The functionalities of this project are supported by a secure by design platform whose characteristics are defined from the technical point of view, considering the generally applicable legal concerns, naturally, such as the European GDPR that has been on the news lately. So, keeping the pace with my previous speaker, we also are using the AI framework, with the AI workflows and the AI models. I won't spend many time here because I believe no one new has attended since he has speaked, but this is the main keystone of our processing, intelligent processing on our project architecture. The main actors on this project are end users, third parties, and external data sources. End users provides health-related data to the AI health system backend, which is one of the services, and allows the control and auditing of the access of any third parties to their health-related data, and all of this is based on smart contracts. He also receives models or data processed by an AI health system backend, central system in the backend. The third party are, of course, hospitals, clinics, research centers, caretakers, or any other entity requesting access and processing of health data on the system that wants to extract knowledge through AI models. All of this access is based, and processing is also based on smart contracts between the third parties and the end user. Of course, external data sources are other platforms other than our AI system, from which the backend may collect subsidiary data for the integration of relevant information for health-related predictions. Access and provenance of external data sources are also regulated by smart contracts. All of this is in terms of AI organized in an intelligent computational services that I'll speak a little bit later after describing the general architecture. So here we have the whole picture. The the part of the end user is the front end, what we call the AI Edge system front end, which is basically a smart device application, which we named AI Health App, that allows the user to capture, store, process, transfer, and receive back health-related data. The AI service backend, which is here in the center, implements the services to securely store, to identify anonymous data, to control entity authentication and access to data, and to license and audit the access to health-related data. All of this through blockchain and distributed ledgers that enable the transparency and auditability of the system. Every provision and access to health data requires the emission of a smart contract that will be stored into the blockchain. The artificial intelligence services are downloaded from the MPI store using the AI workflows and models, and used to directly treat and process the data on the device or on the backend to extract specific knowledge. They enable the training of machine learning models to identify and assist in the identification of medical diagnosis and prognosis. That's the focus here. The access to the health data, the data may be processed, like I said, inside the front end, with no need for a smart contract to process data then. But for the backend, smart contracts allows the processing of the data to serve a request by a given external third party. Of course, these third parties have to be authorized and authenticated to request access using the proper APIs for requesting of data. They will have access to a data catalog using a simple query interface that will be providing the metadata with an appropriate level of detail. The third party can also optionally select some intelligence mechanism in order to process data and extract some intelligence from the data. The following assertion acts as a paradigm for what is specified in the smart contract. The backend grants the external party the right to process the designated data with processing A, B, C, whatever, which involves, of course, the selection of the specific services to process the data, one or multiple services properly orchestrated, as long as the third party has the permission to access the system's data and perform the required treatment. Again, it means that the entity has accepted the smart contract created by the blockchain. We, in the part of the front end, the edge device, the front-end system provides for the end user collection of his or her health data. The end user signs into the AI system equipped with security features and initializes the end user secure data vault. It configures the application to connect with the different needed data sources, external sensors, internal, external applications, wearables, whatever. It configures needed personal or special data like demographic data or biometric data. And the application starts the collection of this data from the end user and the sensors and applications, and securely stores it locally in a secure data vault. When needed, the application requests for permission to export specific subsets of their AIH data to the AIH central system, and potentially, if requested, and the backend will also export it to other third parties, like the clinician that follows this particular operation or something like that. If, in fact, the permission for AIH data export is given, the backend creates a smart contract and the data will be collected via an API into the system for proper de-identification and anonymization before being transferred, if it is the case. Also here, we have the local AIHFL model that will be processing the end user's personal data in order to detect any anomaly, any symptomatic anomaly that may require medical alert. And this is the federated learning part. These edge devices are orchestrated via deployment across multiple decentralized edge devices or servers that will each one hold its local data samples to collaborate in the training of a global model. Beware that no user data will be changed. In the models, only incremental changes from the local model machine are uploaded to the central or global machine learning model that can then use these parameters to improve or update its central models, and if so, it will divulge that new updated models can be downloaded by the edge devices, and if they want it, they will download it and update the local model again. This, again, all over authorization of the user. There is no imposition here, okay? There's always authorization for this. Several functional requirements have been established, like the front end should be persistent and the backend should be persistent also, of course. The calibration of front-end biometric sensors is needed. All the interface between front-end, back-end, third-party, and back-end are regulated by terms and conditions via smart contracts. Third parties can process request data and extract the results of this processing. There are several data types that are possible target for processing, and there's an interface between the actors, the services, and special services like governance service and so on that regulate all this interplay. Of course, we have identified a series of data types to be used in this context. I remember that we're talking about health context and health applications, AI applications. These are the most relevant ones. Of course, there are some others that are needed for the intelligent processing of health data. And where are we in the MPI process at the moment? Well, we are finishing stage 2 functional requirements, and we'll be moving next to commercial requirements. And in the near future, we hope maybe in September, we can be issuing a call for technologies for this project. I thank you, all of you, for being here and bearing with me. I hope you like this project, and we look forward to your participation in this exciting project. So join MPI, share the fun with us, and build the future with the MPI community. Thank you.